this topic is designed for BC. And I teach it to you guys because if you're going to take a college calculus class after this class, they will expect that you've seen this before. And so I try to do what I can, even if it's not part of what you're going to get tested on, for you guys to see it. Because I don't ever know, what your future plans could take you. And while you think you might never need this class, like for the rest of your life, you may decide on a major that strangely requires that you have a calculus class under your belt or two. So, this is the reverse of product rule, but it's used in a specific situation. Reverse of quotient rule, but only used in a specific situation. Okay. Everything else has a use substitution, like application to it. And while I may quiz you on it, on this topic, I will not test on this topic. So your test will only have what you guys did in 3-2 and then use substitution. Okay, I will only test on the integration by parts and partial fraction decomposition to the BC students, not to you guys. Okay, so strangely enough, and if you guys were to look at the video, I have a couple of videos for this this lesson, and the old video that I have, for some reason, I eliminated like the most important part out of the notes that are here, which I left the guidelines for when you use it, but what I left out was the actual formula. So the formula for integration by parts is if you have a strange product, AU times DV, that antiderivative is equal to UV minus the antiderivative of V du, meaning that I would have to take my U and my dV that I was given, find the derivative of U, and find the antiderivative of dV in order for me to be able to use this formula. Now, this formula works every single time. Nobody ever wants to use this formula. So the only time you ever use this formula is if you have LAN. That's it. If you don't see LAN, you don't use the formula. You do the easier method, which I'm about to show you. Okay? Because there's a shortcut to doing the actual formula. The shortcut does not work with LAN. LAN's just odd. So every single situation where if I look at the product and I can't do a use substitution, then more than likely it is an integration by parts. So step 1 is to pick AU, which we call our derivative side, our d dx side. So how I pick my U, I look at both parts that are being multiplied together, and I pick the U to be the one that if I take the derivative of that term enough times, I eventually get to 0. So out of x and e to the x, which one am I going to choose to be my U? X. Step 2 is my leftovers are then my dv, or my antiderivative side. So that is what's left over, which is my e to the x term. That's step 2. Step 3 is to take the derivative of x that I chose enough times to get 0. So the derivative of x is 1, derivative of 1 is 0. That is step 3. All of this that I'm doing right now replaces doing the formula. I could do the formula if I really wanted to, but nobody wants to, because we lose positives and negatives like I did in BC last period. Step 4, wrong color. Step 4 is to take the antiderivative of e to the x enough times to fill in my table. So I'll take it 2 times, which it's just itself. Step 5 is to play tic-tac-toe. Not the way that you want to either. We draw diagonal lines. Top left to the second term on the right. Second term on the left to the third term on the right. And then because my formula, right, is a positive uv and a minus du, vdu, I go plus and then minus. If I had a third line, it'd be plus. If I had a fourth line, it'd be minus. If I had a fifth line, it'd be plus, plus, minus, plus, minus, plus, minus. Step 6, my answer. I take my little sign, which is plus. So he's positive to start off with. I take my x, and I multiply what's across the diagonal, which is my e to the x. Then my, in pink, had a negative, a minus sign. And I had 1 multiplied across the diagonal to e to the x. And then I had a plus c. So my answer, x, e to the x minus e to the x plus c. I know, it's a lot for a Monday. Questions? Anybody blink at the wrong time? It was kind of like that in third period. I blinked at the wrong time. All right, so let's do another one. Oh, man. Okay. Been doing that all day. My wrist keeps touching the wrong thing. Or I choose the wrong utensil. Okay. Step 1. Pick u. So on a d dx side. On a derivative side. So out of x squared and sine of x, which one am I going to choose? X squared. What am I left with? I'm left with sine. That's step 2. Step 3. Take the derivative enough times to eventually give me a big goose egg. So 2x, 2, 0. Antiderivatives are going to be fun with trig. Yeah, just wait to your end question. So the antiderivative of sine is negative cosine. Antiderivative of negative cosine is negative sine, and then a positive cosine. Step 4. Step 5. Draw my little diagonals. Plus, minus, plus. And step 6 is my answer. So I have a plus, I have an x squared times a negative cosine of x. I have a minus a 2x times a negative sine of x. And I have a plus 2 and a cosine of x. Oh my gosh. And a plus c. And then we just clean it up. So negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus c. Questions? Now we gotta do land. It could be worse. You know what's worse than land? Partial fraction decomposition. Okay. So it's u dv is equal to uv minus, integral of v du. Okay. That is the formula. So we still start out the same way. We still have to pick a u, and we still have to pick a dv. But I gotta fit it into the formula. Now, what makes this the reason why we have to do it is, so the whole goal with integration by parts is that that product goes away into something that we did in 3-2, right? A basic antiderivative. So I'm trying to get rid of that product somehow. And I'm left with just an e to the x or just a polynomial. I want to be left with something that's very easy to take the antiderivative of. Okay. So when I go and I look at this, if I pick my dv to be ln of x, then I run into a problem. Okay. Because I don't know what the antiderivative is of ln. Okay. So I have to pick my u to be ln so that I can take the antiderivative of the other thing. Okay. So if I let u be equal to ln of x, then I can pick my dv to be x squared dx. Okay, so same type of thing, but now what's going to be a little bit different is the fact that I only need to do like what I'm doing in my table just once. So I need to find du, and I need to figure out v. So du is just the derivative. So what's the derivative of ln? 1 over x, technically dx. Antiderivative of v would be 2. Antiderivative would be 1/3 x cubed. And then all I'm going to do is just plug it into the formula. So I got to go u times v. So I have to do ln of x times v, which is 1/3 x cubed. And then I have a minus sign. Antiderivative of v, which is 1/3 x cubed, and then du, which is 1 over x dx. Yes, Levi. Yeah, you'll ignore doing plus c until the very end. That's a good question. So the nice thing now is that this weird thing that I have is not so weird anymore. This is actually a 1/3 x squared, which is very easy for me to take an antiderivative of. So my final answer is a ln of x, a 1/3 x cubed, and now I have a minus 1/9 x cubed, and then a plus c. And I probably would want to rearrange this and give me a 1/3 x cubed first and a ln of x. And then my 1/9 x cubed and plus c. So just kind of rearrange that polynomial a little bit around. And then that's it. In theory, with a little bit of magic, if you took the derivative of this, you would eventually get back to where you started. It requires some effort, though. And maybe a little bit of magic. Yes. Because I had a 1/3 here, and then the antiderivative of x squared is 1/3 x cubed. So then the 1/3 times the 1/3 gives me 1/9. Other questions? Before we all take a deep breath to do partial fraction decomposition next. Hey, at least you guys weren't like zero period. They had to watch it on a video because I wasn't here for zero and first today. Then I'm recording this because I realized that the partial fraction decomposition question that I had them do, or it was in the video, is not the same one that's on this page. So the one I had them watch had fractions in it. Surprised nobody said anything to me though. I would have thought I would have gotten remind messages saying, Mrs. Hayden, why is the examples don't match? But maybe they didn't watch the video. All right, questions that you guys have? So the way that partial fraction decomposition shows up on your like quiz, for example, because I wouldn't do it to you guys on a test. It would look something like this. And so how I know that I don't want to do this problem. The only time you ever want to do this problem is when you have nothing else better to do. Okay, so I wouldn't do this, even though I am fully confident in your ability to solve a system of equations at this point, and fully confident in your ability to factor. The reality is that this is going to take you longer than 2 minutes to do. So even though I think you could get to the right answer, I think you have better things to do with your time on an actual quiz, okay, than to do this. The reason why I know this is partial fraction decomposition, I can tell in 10 seconds. I have 2 options for this when it's a quotient. It's either partial fraction decomposition or it's U substitution. The only way this is U substitution is if I take the derivative of the denominator and it cancels out the numerator. And there is no way 2x minus 1 is going to cancel out x plus 7. And at that point, I'm like, and I've moved on with my life. Because I don't care anymore. Because the thing is that it's going to take you, the time that it would take you to answer 5 questions is the amount of time it's going to take you to answer just this one. And to my opinion, that's a colossal waste of time. That's like 20 percentage points versus like 2, right? Not a good use of your time. So at the end of the day, when it comes down to it, that's for every U substitution. The derivative of one thing has to cancel out the problem. And if it doesn't cancel it out, then there's no point in continuing on with the question about cutting your losses. okay, when it comes to this. So when I look at this question, if I were to actually do it, because I had nothing else better to do on my quiz but to do this question, right? It doesn't make any difference whether you put the a over x minus 3 or the a over the x plus 2. It doesn't make any difference whatsoever. You'll still get the same exact answer, okay? Once you split up this integral, the hardest part is the partial fraction decomposition that you learned last year to figure out what a and b are. The actual integral takes you 15 seconds to figure it out. It's the easiest thing ever. The hardest part is figuring out what a and b are, okay? So we go back to our good old advanced math days when math was easy. And the first step is to get rid of my denominators by multiplying by the common denominator on both sides. So I have an x plus 7 on the left. I have an a times x plus 2 and a b times x minus 3. Now I have to distribute my a and distribute my b. So x plus 7 is equal to ax plus 2a plus bx minus 3b. So I group my x terms together and factor out x. I group my number terms together, so my 2a minus 3b. Oh, this should have an x next to it. And then what partial fraction decomposition does is it tells you that the coefficients of x on one side of the equation have to be equal to the coefficients of x on the other side of the equation, which means that my a plus b has to be equal to 1, and my 2a minus 3b has to be equal to 7. I don't care how you want to solve the system of equations. You would like to substitute, go right ahead. Substitute away. Does not make any difference to me. I like elimination only because I like looking at my arithmetic up and down vertically and not having to worry about distributing. So if I use elimination, I would have multiplied my top equation by 3. Multiplying by a negative number would require more effort. And I can cancel out my b's if I multiply by 3. So I would get 10, 5a is equal to 10. So a is equal to 2. And if I know that a plus b is equal to 1, then 2 plus b is equal to 1. So b is equal to negative 1. I did an awful lot of effort to put a 2 over my x minus 3 and a negative 1 over my x plus 2. Anytime what you have in the denominator is linear, meaning of the form y equals mx plus b, it is always ln as your antiderivative. Anytime it's squared, cubed to the 4th power, a fractional exponent in the denominator, it is never ln. It is only ln when it's linear. So it has to be y equals mx plus b. Your x has to be to the 1st power. If it's to any other power, it is not ln. So this is a lot of effort for me to get 2 ln absolute value of x minus 3 minus ln absolute value x plus 2 and a plus c. Stupid. So dumb. like out of all the math I ever learned in high school, the only thing I remember because it gave me like, you know, PTSD is partial fraction decomposition and trig proofs. I think that's the only thing I think I remember. And it's not that it's hard, it's just that it's so tedious and stupid, right? What makes this 1,000 times worse is that I'm going to be giving you guys a Google form at some point, right? That's not the answer that's going to show up on the Google form. What? Yeah, come on. Why would we make anything easy? So I would first move that coefficient of land to my exponent. And because it's a quantity squared, it's always positive, so I could drop the absolute value bars. And then subtraction means division. You're like, of course it does. So I have x minus 3, the quantity squared. But my absolute value still has to stay with the x plus 2 because I can't, you know, I don't know what x is. It could make a negative number, not a positive one. So this would have actually been your solution on a Google form. I know. Questions that you guys have? Because we can. All right. So your end question is question 2. Before you get super excited, because I'm going to stop you from having the same fate as 3rd period. And then 5th period, we didn't get that far because we had problems. But it's really I had problems. But yeah, I'm not doing that one. It's the same thing. Your question 2 is your end question. Before you get super excited about doing integration by parts, know this. The cosine of 5 of x is technically a u substitution when you do your antiderivatives. So when you let that be equal to dv and you have to take the antiderivative multiple times to fill in the table, every single line is technically a u substitution. But I think you're going to recognize a pattern, and then that pattern will carry through if you do any of the other questions. I think you'll see. All right.